We'll now look at the quadratic formula. The quadratic formula is a formula we use to solve quadratic equations. As you recall, a quadratic equation is written in the form ax squared plus bx plus c equal 0, yeah, where a cannot be equal to 0. Okay. Now b can be 0, c can be 0, but a cannot be 0. Okay. And the reason a cannot be 0, because if a is 0, you'll be left with bx plus c, which is really a linear. So that's the reason why a cannot be 0. So a, b, and c are coefficients, okay, of each term, okay, of the terms. So for example, we have x squared plus 5x plus 20 equals 0. In this case, we have here a is 1, okay, b is positive 5, and c is positive 20. So a here is 1, b is equal to 5, and c is equal to 20. Example of another quadratic, we have 3x squared plus, or we can have minus 7x plus 5 equals 0. In this scenario, a is equal to 3, we're getting that from here. B is equal to minus 7, we're getting that from here. And C is equal to 5, and that comes from there. Example, minus 8x squared plus 7 equals 0. In this case, a is equal to minus 8. We're getting that from here. B is equal to 0. Okay, that's because there is no x term. Yeah, no x term. And c is equal to 7. So we did say that b can be 0, c can 0, okay? But a can never be 0. If we look at example, 5x squared. Here we have a is equal to 5, b is equal to 0, c is equal to 0. And this is because there is no x term. In addition, there is no constant term. Okay, so these are the two conditions. So once you know how to identify your A, B, and your C, we can use what is called a quadratic formula. Okay. The quadratic formula tells us that x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2 times a. Okay? Now b squared minus 4ac is called the discriminant, okay, of the quadratic formula. And we'll see later on that if b squared minus 4ac is equal to 0, you will also see that if it's positive, and then you'll also see that if it's negative, what happens. Okay, so we've already seen that since it's a square root, and when under the square root is negative, we have imaginary solutions. Okay? So those are things you're basically going to see. When it's 0, you'll notice that by working through problems, you'll only have one solution. Okay? So, as I said before, the quadratic formula is just a simplified way or a shortcut to solving quadratic equations when they cannot be factored or when they're not easily factored. So we'll look at some examples and then we'll move on to a different method or another method. Yeah, one of them is very common. Okay. So suppose I say solve by using the quadratic formula. And I tell you we have x squared plus 5x plus 6 is equal to 0. So the first thing to do is identify a, b, and c. So we have here a with a coefficient 1. So this is our a. We have b, which will be 5. And we have c, which is equal to 6. And then we write our formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Now it's very important to make sure that the square root sign covers, the b squared minus 4ac. All of that must be under the square root sign. And now we just plug in. So x is equal to, so instead of b, I'm going to write 5. So we have minus 5 plus or minus the square root of, remember b is 5, so that becomes 5 squared minus 4, and I put these in parentheses. So we want to know now what is a. So a we know is 1. Okay, 1. And then we also want to know what is c, and c we know happens to be 6. All of that divided by 2 times 1. So we continue, minus 5 plus or minus the square root of, if you happen to square b, that becomes 25. And if you multiply minus 4 times 1 will be minus 4, times 6 will be minus 24, everything over 2 times 1, which is 2. Simplifying under the square root, so we're simplifying here now, okay? So we have x is equal to minus 5 plus or minus the square root of 1 over 2. And then the next step is to identify if do we know the square root. Do we happen to know the square root of this? So the square root of 1 is 1. So x is equal to minus 5 plus or minus 1 over 2. And then what I like to do from here, I split the problem into two parts now. So we have x is equal to minus 5 plus 1 over 2, and x is equal to minus 5 minus 1 over 2. So I'm splitting it because if you notice here, we have a plus or a minus. So that means one time the problem is going to be a plus, and next time it's going to be a minus. And then finally, we have x is equal to minus 5 plus 1 becomes minus 4 over 2. And x is equal to minus 5 minus 1 now becomes minus 6 over 2. Simplifying minus 4 over 2, that becomes negative 2. And minus 6 over 2, we have x is equal to minus 3. So the solutions to this problem, this quadratic, is x. If we substitute x as minus 2, we'll get it equal, the left side will be 0. In addition, if we substitute minus 3, we'll get 0. And keep in mind our problem, right? Recall x squared plus 5x plus 6 equals 0. So just as a reminder, this 2 here tells us we will have at most, okay, 2 solutions. So we could have got one solution or no solution at all. So our next example, we'll solve, let's see, we have x squared divided by 3 minus x is now equal to negative 1/2. Now this look kind of complicated, but notice that since this is x squared, okay, that more than likely this is quadratic. The highest power is 2. So let's see if we make this look a little bit better. So let's get rid of the denominators first. Okay. So to get rid of the fraction, right? Let's get rid of the fractions. And to do that, we'll multiply by the common denominator. In this case, the lowest common denominator, which is 6. So if we take 6 and we multiply it by x squared over 3, minus, we take 6 and we multiply it by x, and we take 6 and we multiply that by minus 1/2. So notice that this here, 6 divided by 3 becomes 2, so that's 2x squared minus 6x, and 6 divided by 2 becomes 3, so this becomes a minus 3. Now to solve quadratic, okay, to solve quadratic, it must be equal to 0. Yeah? So we'll add 3 to both sides. And if we do that, we have 2x squared minus 6x plus 3 equals 0. Not until now, okay, we can now say that a here is equal to 2. We're getting that from here. B is equal to minus 6. We're getting that from here. And C is equal to 3. We're getting that from there. Okay. You cannot say from the beginning what is A, what is B, and what is C. You could have worked with a fraction. Okay. A here you could have said would have been 1/3. Okay. B would have been a minus 1. But you cannot say C is negative 1/2. This is wrong. Okay, can't do that. So just keep that in mind as you work through these problems. Right, it has to be equal to 0. So now we can apply the quadratic formula, okay, which says that x is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2 times a. And we'll start plugging in now. So x is equal to minus, recall instead of b, I'm going to write minus 6. So we have a minus and then a minus 6. Okay. Be careful that b, okay, is minus 6. Plus or minus the square root of minus 6 squared. Then we have 4 times a times c. A, we know a is 2. And we saw that c is 3. So here a is 2, c is 3. All of that over 2 times a, which we said is 2. So we continue to simplify. Please note that the 2 negative will become a positive. So we have 6 plus or minus the square root of. If we happen to square, okay, when we square negative 6, that turns out to be positive 36. And if we multiply out everything we have over here, if we multiply out everything we have here, that will become minus 4 times 2 is 8, 3 times 8 is 24. Okay? All of that divided by 2 times 2 is 4. We simplify under square root. So x is equal to 6 plus or minus the square root of 12 over 4. And we ask ourselves, do we know the square root of 12? Well, 12 is not a perfect square. This here is not a perfect square. But we know how to simplify it. So we have x is equal to 6 plus or minus the square root of 4 times the square root of 3 over 4. And that becomes x is 6 plus or minus the square root of 4, we know, is 2. We don't know the root of 3 over 4. And now I split my problem into 2. Okay? So we have x is equal to 6 plus 2 radical 3 over 4. And x is equal to 6 minus 2 radical 3 over 4. Okay? So x is equal to, what I like to do at this point, so you can see the reducing that I'm going to do, is write each one of them over 4. Okay? This way you get to see how I reduce. You don't have to do this, but I wanted to show step by step what I'm doing. So this way I think it'll be easier. Now, 6 over 4, you can divide both top and bottom by 2, so this is 3 halves. And 2 over 4, okay, 2 over 4 is the same as 1 half, so this becomes root 3 over 2. Okay, and same thing here, this here becomes x equals 3 over 2, but now minus, and this simplifies to 1 half, so we have root 3 over 2. So here are your solutions, okay? Or you could have written it as x equals 3 plus radical 3, everything over 2, and x equal 3 minus radical 3, everything over 2. So either one of these here will be correct, okay? So you could write your answer either this way or this way. And then you could write it with a negative this way or this way here. So yeah, it's a matter of choice. Okay. So let's look at another example. Solve the quadratic. Solve by using the quadratic formula. X squared is equal to minus 2x minus 6. So once again, because the highest power is a 2 here, this is quadratic. And if you're solving quadratic, it has to be equal to 0. So if you have x squared is equal to minus 2x minus 6, first we need to bring this to that side and this here to that side. And if we do that, we'll get x squared plus 2x plus 6 is equal to 0. Right? Please remember, you can only solve, or you can tell what a, b, and c is when this is equal to 0. So a here is now equal to 1 because there's an invisible 1 there. Okay. B is equal to positive 2 because of this here. And C is equal to positive 6 because of that term here. So quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2 times a. Okay. So we plug in. Okay, let's do some plugging in. X is equal to minus, instead of b we'll write 2 plus or minus the square root of, okay, we have here b is 2, b is 2, okay, so then we have 2 squared minus 4, and then we have 2 parentheses, one for a and one for b, for c. So we see here that a is 1, okay, and we have c is 6. So a is 1 and c is 6. Everything over 2 times a, which we said is 1. So we continue now to make it simple or expand what we have here. Minus 2 plus or minus the square root. We know that when we square 2, we'll get 4. And then when we multiply out all of this here, okay, minus 4 times 1 is minus 4. minus 4 times 6 becomes minus 24, everything over 2 times 1, which is 2. So simplify under the radical, we have minus 2 plus or minus the square root of negative 20 over 2. Now this is what I said earlier. You know that whenever your determinant is negative, okay, discriminant is negative, and I think I said determinant or discriminant is negative, okay, the discriminant is negative, that you will get imaginary solutions, okay? So I think earlier I may have said over here, okay, so corrections, if I did, this here is called the discriminant, okay, the discriminant. So b squared minus 4ac is called a discriminant, in case I said anything earlier. So anytime the discriminant is negative, you'll get imaginary solutions, which we sort of know. So also 20 is not a perfect square, so we'll simplify this, okay? So here we have x is equal to minus 2 plus or minus the square root. Let's take out the negative 1 times the square root of 20 over 2. So I'm doing it step by step. You could combine these two steps that I'm doing. And then 20 can also be simplified. So this becomes x is equal to minus 2 plus or minus the square root of negative 1 times the square root of 4 times the square root of 5. Everything over 2. So what I did here is that the first step I took out the negative, right, which is this here. And then the second time around what I did, I broke 20 as 4 times 5 so I could simplify it. So you could combine these two steps if you want, okay? You didn't have to do the top, you could have just run straight to the bottom. So we have now x is equal to minus 2 plus or minus the square root of negative 1 is I, and then the square root of 4 is 2 times 5 over 2. And usually we write that as minus 2 plus or minus, okay, this should be square root of 5, 2i root 5 over 2. Because they all have multiplication, right? Order doesn't matter. Now, I break my problem up into 2 parts. So we have x is equal to minus 2 plus 2i root 5 over 2. And x is equal to minus 2 minus 2i root 5 over 2. And this can both be simplified. So once again, I break it up so you can see what's going on. Okay. And as I said, I only do this so that you can see the cancellation or the reducing that I'm about to do here. So negative 2 divided by 2 becomes negative 1. And also this 2 can cancel out with that 2, leaving with 1. So we just left with I root 5. Okay. And then on this side here, same thing will happen. This here, negative 2 divided by 2 is negative 1. And negative 2 divided by 2 again happens to be negative I. root 5. Okay, so here are the two solutions to our problem. Okay. So as you can see, the quadratic formula is just cases where, you know, the steps are pretty straightforward. It's a lot of algebra. Yeah, lots of algebra. So we've seen a case where we have imaginary solutions. Imaginary solutions. We've also seen a case where we have two real solutions. Okay, these are real. They may not look pretty, but they're real. Okay. Likewise, in our first example, we have cases where we had two real solutions also. Yeah. X was equal to -2 and x is equal to -3. So there's also a case where when the discriminant happens to be 0, that we wouldn't have two real solutions. So if we look at this example here, solve by using the quadratic formula. So it is equal to 0, okay? It is equal to 0. So x squared plus 8x plus 16 is equal to 0. So note that it is equal to 0, so we don't have to move anything around. So automatically we can say here that a is equal to 1, which is that coefficient there. B is equal to 8 and C is equal to 16. So our formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2 times a. So if we plug in values now, we have minus, instead of b, we'll write 8, so parentheses, plus or minus the square root of 8 squared minus 4 times a times c. Okay, so a we know here is 1 and c we know is 16. So I'll write a as 1, c as 16. Okay, everything over 2 times a, which is 1. So x is equal to minus 8 plus or minus the square root of 8 squared is 64, and then 4 times 1 times 16, okay? 4 times 1 is 4, and 4 times 16 happens to be 64. So that becomes minus 64, everything over 2 times 1, which is 2. Simplifying under the root, so we have minus 8 plus or minus the square root of 0 over 2. And keep in mind here that I've wanted to point out is what happens when the discriminant is 0. Okay. Well, the square root of 0 is 0, so x is equal to minus 8 plus or minus 0. Right? So note the square root of 0 is 0. Everything over 2. Well, we don't need to write plus or minus 0 because this here doesn't have any value. Okay? So what we're left with is really x is equal to minus 8 over 2. Okay? So x happens to be equal to minus 4. Now, this is really called a repeated root, as you will see later on when we touch pre-calculus and we look at quadratic equations and graphs. So here we only have one solution, okay? Only one solution. And as we said before, when we have an x squared term, we can have at most 2 solutions, meaning we could have 2 solutions, We can have one solution, or we could have no solutions at all. Okay? So I think I've covered the different ways of what will happen in any quadratic, where we can have an imaginary solution, we can have one solution, or we can have two solutions. And I've also showed you how to work with quadratics when we have fractions. Okay? So I hope you can now take what I've given you and be confident enough to solve any quadratic equation by quadratic formula. In my next video, I will show you how to solve quadratic equation by completing the square. Thank you.